Our time is in the afternoon, so good afternoon, everyone. My name is Geoffrey, as the convener has introduced. I also heard the questions raised to our previous presenters regarding how the building and construction community can contribute to smart cities. So my presentation today is more about how our building and construction community can contribute to smart cities. So I'm going to introduce a specific research project which looks into the use of 3D spatial analysis technology to investigate the possibility of minor relaxation of plot ratios and building height restrictions in a particular area in Hong Kong. But before that, I will also give you a bigger picture about how the government push the development of smart city in Hong Kong. So if I may, I can change to, how do I move to the next slide? Maybe just that? No. I'm trying to learn how do I move to the next slide. Okay, maybe this one. Okay, here we are. So you can still see the screen, right?
Yes, thank you. Yes.
Good. Now this is a greeting from the Hong Kong Polytechnic University. This is my workplace, and in contrast to the previous two speakers, we are a university. And my specific department is building and real estate. In short, it's also BRE, interesting enough. Okay, so now, before I go into the presentation, I would like to put things in perspective. I think there are many different definitions on smart cities, and there's no one universal definition for smart city, but there are some common features of smart city. Number one is a city that leverage on information and communication technologies and use innovative solutions to address issues in a city, including governments, economy, mobility, environment, living, and people. And number two is to aim to improve the quality of life of the people living in the city and the sustainable growth and the competitiveness of the city through smart initiatives. So these are the two common features of smart cities, and you can see it's very broad. That's why we have people working in the information telecommunication industry. They are working in this area of smart city, but also building, construction, community planning, architecture, etc. So as I mentioned, my angle is primarily from the building and construction background. Okay, in Hong Kong, the chief executive has announced that this is recent in the 2015 policy address. The government would explore to develop Kowloon East, which is a part of the city, as a pilot area to explore the feasibility of developing a smart city. In fact, depending on how we define a smart city, Hong Kong has been regarded by some authority ranking, indexing agencies. It's already a smart city. But of course, we are a bit modest. We believe we are still having room to develop. So that's why we try to say we want to explore the possibility of developing in one possible pilot area. Okay, in this policy address, the government also mentioned that we want to examine the feasibility of using technology to enhance pedestrian and vehicular accessibility, managing district facilities and disseminating information to the public in digital format, etc., with a view to make the area a better place for work and play. So this is one of the initiatives introduced by the government recently. And when we talk about the smart city, we have these number of things in mind. Okay, apart from Hong Kong, you probably also know there are smart cities in other countries and cities in Asia, like South Korea. We have Seoul as a smart city, and Singapore as another smart city, and Tokyo in Japan. But I'm not going to touch the other smart cities, but to focus on Hong Kong in particular. So when we talk about smart city initiatives, we have the following items in mind: smart economy, mobility, environment, people, living, and government. So when we talk about smart economy, we have things like high-speed internet infrastructure and e-commerce, and we use widely this particular card called Octopus, which enable, basically it's RFID card, which enable people to store value inside and use it in public transport, in canteens, in some supermarket, etc. So it's widely used. Octopus. So this is regarding e-commerce in our economy. In terms of mobility, we have a very good public transportation system, as you probably know, and we also have a very good freight logistics and traffic information system. But of course, there are still rooms for improvement. And environment, we have planning, land use, and smart buildings. This is particularly related to the building and construction community. Land use, smart buildings with zero carbon buildings, examples, renewable energies, etc. And smart people using mobile, broadband, etc., using ICT, and smart living, basically enhance quality of life through the means mentioned above. And e-government, there are a lot of electronic services provided by the current government. So this is the few things we have in mind when we talk about smart city development. Okay, then I move on to this is another recent initiative called Smarter Hong Kong, Smarter Living. Within this, under this initiative, we have, for example, specific initiatives trying to develop Wi-Fi hotspots, trying to disseminate information through internet, try to digitize government operations, and Internet of Things, as David mentioned. This is something we have also a very good infrastructure and a lot of work into this area: sensors and big data, etc., and digital identity of citizens. So there's a number of initiatives under this Smart Hong Kong Smart Living program. And I mentioned Kowloon East as a pilot area. So basically the government wants to make this area a better place for work and play, and trying to incorporate technologies to enhance the pedestrian vehicular access, manage facilities, etc. And you make this place a workable place. So you don't need to rely on any means of transportation, but simply work from one place to another. And green community in terms of energy use, and also using smart technologies like Wi-Fi, wireless networks, etc. So this is the big picture. And look into the projects, and if you have the definitions I gave early on regarding smart cities from the building construction community's perspective, this is one workshop we have organized quite a few years back in 2007 to look into collaborative human futures, how different professions can rely on technologies to support and collaborate. This is one of the end products called Collaborative Construction Information Management. This is a book edited by myself and other two colleagues, Peter and Andrew. Now, let me go back specifically to this research project. This is our team. As you can see, this is a very multidisciplinary team. We have people like Stanley Young, he's a town planner. We also have Abby Wong, and she is specializing in land use policies. We have Dr. Charles Wong. He specializes in heat island effect, air temperature, wind ventilations, etc. in the city. And Dr. Guo on data collection, spatial analysis, etc. So we have a few other colleagues as researchers involved in the project. Now the background, so this is the few things I want to cover: the background of the project, research objectives, methodology, findings, and summary. A little bit background about the project. In fact, we look into the old Kai-Tak airport area. Some of you who were in Hong Kong before, you know we had, this is our old airport. And in 1998, we have moved the airport from this old location to the current location. So the old airports are now open for redevelopment. So what we are trying to do is to look into some of the land provision issues within this particular old airport area. As mentioned, we have a Kai-Tak development plan. As you can see, from 1998, after the airport has been moved to a new location, we have a number of initiatives by the government trying to redevelop this area. So I don't want to go into the details. For example, we have outline zoning plan for this particular area. Okay, now our focus. This is one site visit we have conducted. As you can see, there are a lot of construction work and land to be formulated for development. This is actually just a few months back when we paid a site visit to this area. Now, our focus is on these three particular areas, altogether 21 pieces of land. We look into the possibility of and the impact of minor relaxation of plot ratio and building height restrictions on a number of things, such as the skyline, the shadows, air temperature, wind ventilation, etc., to see what are the impacts. Of course, there are many other things we didn't touch. For example, excuse me, environmental impact analysis and transportation, for example. But our focus is to see how we can use 3D spatial technology to support our analysis in looking into possible relaxation of this 21 sites in this development area. Okay, now this is the three area as I've mentioned. This is actually the three, 1, 2, 3. Altogether, it consists of 21 pieces of land, and we want to look into how the relaxation may affect the lightings, the ridgelines, air and ventilations, etc., by using 3D spatial technology to support our analysis. So specific research objective is to investigate the viability of minor relaxation of this site in column 3 through 3D modeling and spatial analysis. So the two specific objective is to establish a 3D model and to conduct a spatial analysis of the different plot ratio, building height, etc., on this the impact, like shadow, solar exposure, skylines, etc. Okay, so I'm going to introduce those in detail later on. Okay. Now this is the research methodology. I think I already covered that we want to look into the skylines, the visual impact, the wind ventilations, shadows, and air temperature, to see if we relax the restriction, how this will affect all these different things in this particular development area. Okay, now this is the development of our 3D model. So we have bought some data from the government, which including buildings, infrastructure, and some terrains, to help us to establish. This is the old airport, the runway, as you can see, and this is the area we try to develop our digital model. So it's not just the 21 sites we try to focus, but also the surroundings, because we will have some interrelations and interactions in terms of shadows, air, and the skylines, etc. So we have to buy to have the digital model for quite a large area of this part of the city. And we followed two things in particular during the scenario development. One is the outline zoning plan, the other one is the building regulations. So I don't want to go into the details. These are the, if you like, the constraints and the guiding principles we have to follow when we develop different scenarios. Okay, now this vertically, this column represents one particular site. We didn't list all the 21 sites. This is just a few examples of the site. And what we have done, we have developed basically 4 scenarios, different scenarios. And scenario 1 is the current situation in terms of a plot ratio, in terms of building height, etc. And the scenario 2 is, as you can see from this particular illustration, scenario 2 is one already approved by the town planning board to increase the height restrictions and plot ratio roughly by 22%, already approved. But we want to explore if we want to further relax, increase the height and relax the plot ratio. So we create scenario 3 and scenario 4. Scenario 3 is half of this previous increment, and scenario 4 is the full amount of the previous increment. So altogether, you can see we have created 4 scenarios for all 21 sites and to look into the development. Okay, now you can see this is area 1, for example. We have actually somehow the animation doesn't work. We have animation to illustrate how the different scenarios change in terms of building height, etc. But anyway, you can have some ideas already. And this is the models we have developed for this new area, because this is still empty land. So we have used our imagination and use those constraints we have mentioned earlier, trying to develop a possible solution for this development. Okay, area 1, 2, 3. Okay, area 3 include commercial elements and also residential elements. Okay, so what we have done in terms of okay, now you can see the model. This is the area 3, area 1, area 2. So this are the models we have developed ourselves. This is a closer look of the area 3 and other 2 areas. Okay, now we come to the analysis we have done by using the 3D models. The first one we have done is a skyline. Now you can see this is one particular section. We have it's called Skyline 1, and this is another section called the Skyline 2. And if you go into the system, because of the 3D model, it can actually help us to generate this skyline fairly easily. And we can compare scenario 1, 2, 3, 4, how the skyline change. Okay, because the height will be different, the plot ratio will be different, side coverage may also change, and to see how it affected the skyline. So this is one thing we have done, and this is the second line, a different cut. You can see the difference between the 4 different scenarios. And then we have done another analysis called visual impact on the ridgelines. For those who have been to Hong Kong, you probably know we have the Lion Rock Mountain, which is considered as an asset of the city. So all the development should observe the ridgeline. This is of course not a compulsory, but it's a guideline. So we have done this trying to look into how our development affect this ridgeline. Okay, so if I show you this. Okay, now we have to use 3 particular points trying to look over to those ridge lines. So we have a point here, and point here. There are 3 different points, and trying to look over to this development area. So this is Victoria Harbour, if you are familiar with Hong Kong. And by looking into the mountains at the back to see whether the development we have here block our views of the mountains, the ridgeline so-called. So this is the ridgeline we have in mind, and what we have done, we have used the lines to go from these 3 particular locations and to see whether our views will be blocked by this new development. So as you can see, none of the views are blocked in all these different scenarios. So that's one result. We can say by having these 4 different scenarios, it does not affect the ridgeline at the back. Okay. So other analyses we have done include, for example, shadows and solar exposures, to see how these different scenarios affect the shadows and the solar exposure of this particular area and surroundings. Okay, we also have some animation. Again, it doesn't work. It actually shows 24 hours. How does it change? Okay, don't worry. So this is still solar exposure. And then we also did something like the shadows to see how it affects the lightings and those people who are living in this area. This is solar exposure. You can see the right are the area where you can receive the sunlight, and the blue are the shadows, and you can see the different area and the different scenarios. So by having this information, we can have it visually the information to facilitate the discussion. So this is spatial analysis. We have some data to show how the solar exposure may be affected by the relaxation. So without going to other 2 areas like wind ventilation and air temperature, because that will be too much. So just want to say through this analysis, we have concluded that there are only minor effect on skyline, no visual impact on the ridgeline, slight change on solar exposure, slight change on wind and air temperature. So basically, the presentation I try to illustrate is how our building construction community can make good use of technology like what we are using 3D spatial analysis, GIS, city engine, and to support the possible development scenarios. We don't have any specific views, but by having the data in front of people, it will facilitate the discussion. So that's all from me. Thank you very much.